Welcome back, guys. I hope you watched the first three videos on Pythagoras theorem, and today we'll move ahead with the fourth video. In this part of the video, we will going to learn some proof sums of Pythagoras theorem. Basically, we're going to try to cover exercise 13B's first few questions so that we'll get the grip on the chapter. So in case if you have not watched first three videos, so these are the glimpses of what we learned in the first three videos. So Pythagoras theorem is about right angle triangle in which angle B is 90 and AC is called as hypotenuse. This is the longest side of the right angle triangle. Then we saw how to calculate if the hypotenuse is missing or one side is missing, then how to find it out by using this formula. This is a Pythagoras theorem formula. So we saw AC square is equals to AB square plus BC square, and then do substitute the values and we're going to get the missing side. And then we saw some Pythagorean triplets like 3, 4, 5, 1, 1, root 2, 5, 12, 13, and something like that. And if you could do multiply by 2 of each side, still they would be triplet. If you multiply each side by 3, still they will be triplet. Then we saw a few sums yesterday's class, say sum number 1, 2, 3, 4 from exercise 13A. We saw many sums, and then today it's time to move ahead with the proof sums. So what are these proof sums? We'll see slowly and gradually, guys. They are very important, very important, because each sum comes for 4 marks in your school examinations. Apart from that, it has like really good concepts. So let's learn these concepts in detail, guys. Okay, so let me just take the sum on the screen. So meanwhile, keep your notebooks ready. So students, how to do these proof sums? Let's see with this example number 1. So this is example number 1. Look at this. You have to strictly follow a right triangle. Okay, you have to strictly observe the right triangle. If you follow this rule, many sums would be very simple. Say AD is perpendicular to BC. AD is perpendicular to BC. Means what? AD is perpendicular to BC means it makes 90-degree angle. Line AD makes 90-degree angle with side BC. That means this is a right angle. Isn't it? ABD. ABD is one right angle and ACD is a second right angle triangle. So there are two right angle triangles. Okay. What we have to prove that? We have to prove that C square is equals to A square plus B square minus 2AX. So this is what we have to prove. And then they have given some alphabets. So this is side X, this is A minus X, this is side C, and this is side B. So in general, you remember students, in a right angle triangle, the angle opposite, okay, if the side AB has opposite angle is equal to capital C, then this side, length of the side is C, AB is denoted with small c. You understood? If, okay, now, okay, this is the side. Okay, this is the side, like side AC, which is opposite to angle B. So this would be general. It is in general denoted as small b. Are you understanding? So this is like the general rule, not hard and fast. Okay, it has to be always like this. And this is the height. Altitude is general denoted with the alphabet H. Okay, now how are we going to prove this? It's very simple, very simple. Stay tuned. I'll explain to you very well. Okay, now I'm selecting triangle ADC. In triangle ADC. Hopefully you finish writing the sum and now you'll start writing the proofs. If you have not finished writing the sum, pause the video, copy paste this sum. I hope you finished the drawing the diagram, and now let's begin. In triangle ADC. Now what is the reason? What makes me think to choose a triangle ADC? You'll understand shortly. Look at this. Here if you'll say angle D is 90 degree. Angle D is equals to 90 degree. Or rather you can say angle ADC is 90 degree. Angle what? ADC is 90 degree, isn't it? But angle ADC is 90 degree. Because D is not clear over here, which So ADC, if it's 90 degree, then by Pythagoras theorem, by Pythagoras theorem. What we can say? Statement number 1. B square, that is hypotenuse square, is equal to one side square, that is h square, plus x square. I am writing very slowly so that you all can understand perfectly. So we thought hypotenuse square, which is b square, is equal to one side square plus other side square, isn't it? Now, after writing this, what we can do, students, we'll have to choose another triangle. What could be another triangle? Or else you can make over here one more statement. Therefore, h square is equals to b square minus x square. Therefore, h square is equals to b square minus x square. This you can say statement number 1, or you can say statement number 2 also. Say this is statement number 2. Now, in triangle, now I'm choosing second triangle, ADB. In triangle ADB. What's there in triangle ADB? Angle ADB is 90 degree. Could you see? Angle ADB is 90 degree. If angle ADB is 90 degree, students, what we can say? By Pythagoras theorem, what we can say? C square, statement number 3, hypotenuse square is equals to one side square plus other side square, that is a minus x the whole square. Okay, again over here, if we'll make the h square as a subject, what will become? H square is equals to c square minus a minus x the whole square. I'm just shifting this term to the other side of the equation, isn't it? So this positive term became negative. Are you getting it? It's a very simple, guys. Now, once you're done with this statement number 2 and statement number 4, what we can do? Look at this. Now, if you'll notice, in prove that part, there is no h square anywhere, isn't it? So I am equating this 2 and 4, equating this 2 and 4. See, this is also h square and this is also h square. So if we'll equate from 2 and 4, what we can get? We can get c square minus a minus x the whole square is equals to b square minus x square. Okay, now let's see where we have to reach. We have to reach a square plus b square minus 2ax. No worries. Oh, okay, so we just want over here c square. We do not want all these things, isn't it? So you can just shift this on the other side. So this will become c square is equals to b square minus x square plus a minus x the whole square. You understood? Now, are we close? See, did you notice I am again and again coming and checking where we to reach? I had to reach in the left hand side c square, which I reached. And now only the right hand side is left over. Again, I guess even that is very simple. Now I just need to simplify. B square minus x square plus a square plus x square minus 2ax. Now, if I cancel this x square and this x square, you're going to get this as a square. Okay, so we got c square is equals to a square plus b square minus 2ax. And that's all. Hence proved. Hence proved. You understood how to prove? Hence proved. Basically, this is geometry. These proofs are geometric proof, but lots of algebra is involved in these sums. So many people, like, they get, oh my God, how we will be able to do and all that thing. things. Basically, these all these things you can write below this. I just wanted to save the space, so I have arranged it in this form. I hope students you understood this. So what was the logic? There was no h, and the h was a common side. So I made equation number 1 in format of h. I made equation number 4 in format of h, and I just equated. When I equated this both right hand sides, so h got eliminated, and then finally I got all the things in the term of c and a and x and something like that. I hope you understood this, and you will be able to do this such type of sums if they come. Hopefully you liked it. You can pause the video and write it on this very neatly and very beautifully in your notebook. So pause the video. Okay, students. So this is sum number 2 in front of you. It's something said in equilateral triangle ABC. So let's draw an equilateral triangle. So this is an equilateral triangle ABC. What do you mean by equilateral triangle? All sides are equal, all angles are equals to 60 degrees, and so on. AD is perpendicular to BC. AD is perpendicular to BC. Do you remember in last video I mentioned to you something? When side AD is perpendicular, it bisects this base, isn't it? It's an equilateral triangle's property. And BC is equal to x. BC is equal to x. That means this will become x by 2. Find in terms of x the length of AD. So we're supposed to find the length of AD in terms of x. Now, of course, this length BC has to be same as AD because they are the sides of the equilateral triangle. So you are supposed to find the length of AD in terms of x. It will be root 3 upon 2 into x. Yhi final answer hona chahiye, but still we'll try to find it out because that's the standard formula of an equilateral triangle, isn't it? What is the height of an equilateral triangle? The height of an equilateral triangle is equals to root 3 upon 2 times of the side. This is the formula. Here we are supposed to reach. This is what I know it, so I could write, but ultimately you are supposed to reach over here. So that is the AD. AD is nothing but height, isn't it? Now, how to think about this? So let's start writing. In triangle ABC, okay, AB is equals to BC is equals to AC is equals to x centimeter or x meter, you can say. X centimeter it's mentioned, so I just wrote because it's an equilateral triangle, isn't it? And since equilateral triangle, you can write this since reason over here also, because I do not have space, so I just wrote it below side. Then we can say that AD is perpendicular to BC. Second, AD is perpendicular to BC given. Therefore, we can say third statement, BD is equals to CD is equals to BC upon 2, which is x upon 2. The reason is perpendicular drawn in equilateral triangle bisect the base. I hope you are aware about this. We've already discussed this property in the last exercise, in the last video, isn't it? Okay, next one. Now in triangle, which is a triangle now we're going to choose ADB. In triangle ADB, okay, it looks something like this. I'll just flip it. Something looks like this. This is A, this is B, and this is D, and this is perpendicular, and this is x by 2, and this is what it is supposed to find, and this is x. You know? So in triangle ADB, angle ADB is equals to 90 degrees. Now many people tell me, sir, we don't know how to write the proofs or how the writing comes. We don't understand. So students, always remember that when you say that you don't know it, so what you can do, you can simply write it down the way it comes in your mind. Don't worry, in one go it won't come so easily, but when you write third or second or third time, it will come systematically. Okay, so I have written this proof n number of times, so it comes very nicely in my book. But when you will try to write, you write very systematically the charts. Okay. So by Pythagoras theorem, what will happen? I am writing by PT, but you do not write that. Your teacher may not give the full marks. Hypotenuse square, x square is equals to h square plus x by 2 square, isn't it? H stands for height, which we are supposed to calculate. So h square is equals to x square minus x square upon 4. And now if we'll go keep forward ahead solving this, so h square will become 4x square minus x square upon 4. So h square will become 3x square upon 4. And now if we'll take the root on both sides, it will become root 3, x square ka root will become x, and 4 ka square root will become 2. So the height of the equilateral triangle is root 3 upon 2 times of x. You understood, guys? Centimeter. That's it. So simple, isn't it? I hope you understood this. Here, this is what I had already mentioned here. Where you are supposed to reach, height is equal to root 3 upon 2 into x. This is what I knew, so I wrote. But in case if you're not aware, nothing to worry, guys. I hope you understood this entire sum. It was little long, you must have felt, but not at all. Not at all. Only one triangle you're supposed to choose, and this writing is only how this side we got, how this BD we got, and that explanation, isn't it? So this writing part is very, very important, guys. Keep writing the script. So pause the video and copy paste. Let's start with one another sum number 3. Triangle ABC is a triangle and right angle at B. So I'll just draw the triangle. Guys, please draw the triangle. It will always help you a lot. A, B, and C, and it is right angle mentioned that it's at B. M is a point on side BC. So I'm just placing point M over there. Prove that AM square plus BC square, AM square plus BC square is equals to AC square plus BM square. Now how am I going to get this? So if you're not understanding, no worries. Just keep following my instruction. Now, what was the rule I mentioned in the beginning itself? Always choose only right angle triangles. Always choose only right angle triangle. So ABM is a one right angle triangle and ABC is another right angle triangle, isn't it? So सिर्फ Pythagoras theorem लगा दीजिए and then equate the side and just shift the sides here and there, you will get this proof part. Are you understanding? If you have not understood, nothing to worry. Just pay attention over here on my writings and you will get this. We're to reach AM square plus BC square, isn't it? AM square plus BC square. We're to reach it there. Let's begin. So in triangle ABN, angle B is 90 degrees. Here I can write directly angle B is 90 degrees because angle B is very visible. It is 90 degrees. Therefore, by PT, what we can say by PT? We can say hypotenuse square. Where is the hypotenuse? AM is an hypotenuse. In the small triangle, AM is an hypotenuse. So AM square AM square is equals to AB square plus BM square. Once you get that, look at this. AB is a common side between these two triangles. So I'll write in terms of AB. Everything I'll write in terms of AB. So AB square is equals to AM square. Once I shift this other side, it will become minus BM square. minus bn square. And this is your statement number 1. Okay, this is the first part of the proof. Now let's begin with the second part. What is the second part? In triangle, now I am choosing triangle ABC, a huge triangle, isn't it? In triangle ABC, angle B is 90 degrees. Therefore, by PT, what we can say? By PT, what we can say? Hypotenuse square. Where is the hypotenuse? Side AC is in hypotenuse. So AC square is equals to AB square plus BC square. Now once again I'll write everything in terms of AB square. AB square is equals to AC square minus BC square. This is statement number 2. Now if we equate statement number 1 and 2, look at this. This is also in terms of AB square and this is also in terms of AB square. Now how do I come to know why I have to make this in AB square and AB square only? Because in these two triangles, AB is the common side. So I made the statements in terms of AB, and now you'll see the magic. What is the magic? Once you compare them, look what happened. Look very carefully. AM square plus AM square minus BM square is equals to AC square minus BC square. Okay? Now look, where we to reach? We had to reach over here. AM square plus BC square. So that is in the left hand side. So if we get this BC on this side, it will become AM square plus BC square, which equals to AC square plus BM square. And that's it. That is what we have to prove, isn't it? Hence proved. Did you understand? It was super duper easy. But you should have the logic, how to get the triangles, how to choose the sides, and how to get them one on other side, and how to compare and what to compare. Then only you'll be able to do this. So see in the next video, we're going to do many interesting questions. So see you in the next video. Till then, bye bye.